All right. This is section 1.5. Section 1.5. This is we're going to get in. This is what you want to take notes on. Your learning target for today.
Tell Mr. Bradley.
Solving inequalities. Inequalities. We've been working with equal signs, right? Now inequalities. Less than, greater than, less than or equal to, greater than or equal to. Okay, what does it mean? If I said 3 is less than 4, that's a true statement, right? If I said 4 is greater than 2, that's a true statement. Is this true? 3 is less than or equal to 4. Is it less than? Or equal to? Yeah, it's true. It's less than. It's less than. Can I say 4 is greater than or equal to 2? Yeah. It's not equal to, but it is greater than, right? Can I say 4 is less than or equal to 4? Yes, because it is equal to. It's less than or equal to. You guys getting how this works? All right. that was a bear. All right. Okay, let's learn some things about inequalities. Inequalities a lot of time are given to you in an equation type form. If you notice right here, 6 plus x is greater than or equal to 20. 6 plus x is greater than or equal to 20. We can treat, now here's going to be a rule I'm going to teach you. We treat this just like this was an equal sign. All right? Until one thing happens, and I'll show you that one thing. There's one thing that can take this sign and switch it around. All right? But I'm not. Treat it just like an equal sign, but there's only one case where it'll switch it around. So if we treated this like an equal sign and I wanted to solve for x, what would I do? A minus 6, right? I got a plus 6 here. I bring it to the other side, and it's going to be a minus 6. All right? Then x is greater than or equal to 20 minus 6, which is 14. All right? Acts the same way as if it was an equal sign. Yeah, that's it. X is greater than or equal to. What does that mean? It means that if I put 14 or any number greater than 14 into this x, replace it, it's a true statement. Let's see if that's true. 6 plus 14 is greater than or equal to 20. Is that true? 6 plus 14 is what? 20. 20 is greater than or equal to 20, right? True? What if I put a bigger number in here? 6 plus 17. Is it greater than or equal to 20? Because that's 23, right? Is 23 greater than or equal to 20? Yes. It's greater than or equal to 20. So it makes it a true statement. All right? That's where our inequalities come in. Let me give you the one exception. All right? You treat this like it's equal sign except for one time. And that's when you do this. Let's say negative 2x is greater than or equal to 20. Negative 2x is greater than or equal to 20. Notice that I'm multiplying by a negative number. All right? If I'm multiplying or dividing by a negative number, when I bring this to the other side, this sign switches. So when I divide this by negative 2 and this by negative 2, all right, I come up with x is less than or equal to now negative 10. Okay? Only time that you don't treat it like an equal sign is when you are multiplying or dividing by a negative number. That's the one exception. All right? Underline the word or words that indicate an operation, the product of 12 and a number. I don't even worry about that. Operation. They're all operations. All right, circle the word phrase that identifies the inequality to use. Then write the inequality that represents the sentence. The product of 12 and a number is more than 190. What inequality sign are we going to use? More than would be greater than, right? More than would be greater than. So I would write this here. The product, 12 times the number A, so I'm going to say 12A is greater than 190. Okay? 8 is less than a number is at least 34. 8 less than a number than a number is at least 24 or 34. So I take a number, right? Take a number, I go 8 less than that, right? Which would be minus 8. At least that, which would be what? It would be less than or equal to, because it's at least that. It could be more, but it's at least 34. The difference between a number and 24 is no more than 4. The difference between a number and 24, a number and 24, the difference is no more than 4. Less than or equal to 4. The sum of twice a number is, and 7, is less than 25. The sum of, what's twice a number? 2 times that number, right? So I can say 2A and 7. So the sum, so we're adding here, saying plus 7, this is 2, is less than 25. Make the less than sign, 25. See how we got those? Work through them step by step. Any questions?
I get it.
I don't want to capture. I want to clear. See, is there any more in this? I want to go over. There's a sentence in the operating equality. Don't worry about the operation equality. Operation. 4, let's see. Inequality, 4 is greater than a number. See, a number is 4 greater than, okay. Inequality, greater than would say 4 is greater than, in other words, greater than that, than a number. They've got the 2 numbers, I guess, the way they signify here. Here it's saying it's 4 greater than, we're talking plus. Don't worry about this. We're not going to test on that. I'm not even going to worry about it. That just confuses people as far as I'm concerned. So I didn't really say anything to you guys. All right. Who used to talk like that? Would you guys even know? No. You guys ever watch Batman and Robin? Did you? Yeah, this is the practice, right?
Yeah,
Practice. This is practice 5-2. Oh, I hate it when it does that.
Oh, ain't that something?
It's something.
I hate when it's a nice day outside.
All right, we just did practice 1. We're going to do practice 2 here real quick. Same kind of stuff. 4 less than a number is greater than 28. Let's go around. Ty. 4 less than a number is greater than negative 28. X minus 4. Good job. Preston, twice a number is at least 15. At least 15. Greater than or equal to. Tyrese, a number increased by 7 is less than 5. A number increased by 7, n plus 7, is less than 5, right? Yep. Katie, the quotient of a number, n8, is at most negative 6. Quotient is division. At most. Less than or equal to, right? Negative 6. All right. And then it says graph solutions. This is going to be graph solutions. I'm going to show you real quick about graphing solutions. I want you to work on this. This is going to be part of your assignment. So make sure you know what you're doing here. You can grab graph. There's graph paper in the bottom drawer over here. All right. First thing I'm going to do in this, when I graph this, is I'm going to solve this equation. All right? That bottom drawer right down there on the left. Bottom drawer.
Yeah, me too, man.
All right. First thing I'm going to do is I'm going to solve this. So I'm going to look at this and I'm going to say 3x plus 1. I'm going to carry my 3 through. Pay attention, guys. 3x plus 3, because I carried my 3 through, plus 2 is less than 11. All right. I'm going to add my 3 and 2 together, and I'm going to bring it to the other side. 3 plus 2 is 5, right? If I'm adding 5 over here, I subtract 5 over here, so I could say 3x is less than 6. X is less than 6 divided by 3? 2. 2. So I'm going to graph this. Here's what's going to happen. I'm going to make my graph. 1, 2, 3, 4, 5, whatever. X is less than 2. When you graph, this is really important to notice. When it's a less than or a greater than, your graph lines are a dashed line. That signifies that it's less than or greater than, okay? If it's less than or equal to or greater than or equal to, then it's a solid line. You have to signify, you got to note this. Now, x less than 2 means we're starting at 2, and we say x is always less than 2. So we can start here. Solid line or dashed line? Dashed line. It's always less than 2. Now, I've got a dashed line at that, but I have to shade in what numbers would be less than when x is less than 2. Where is it? Is it on this side or this side of that line? That side? Is 3 less than 2? Okay. Here's what you can do, and always remember this. As long as the line doesn't go through this origin point of 0, 0. Okay? That origin point. We can use that point as a reference to see which side of the line we're going to shade. Because if I put 0 in for x, and I have x is less than 2. If I put 0 in for x, if that's true, then whatever side that point is on is the side we shade. If that's not true, then it's the other side. Okay? So in this case here, it is true and 0, 0 is on this side of that line, so we shade over here. All right? Do you see that? If I put 0 in for x here, this statement remains true. That means where my x is 0 is going to be the side we shade on. What if it was x is greater than 0 or greater than 2? And we put 0 into this. Would that be true? No. 0 is not greater than 2, so the origin's over here. This side isn't true, so this side must be. That would be the side we'd shade in on. You guys understand how we're doing that? You guys ready to try the assignment? Good, because we're almost done. All right. Let's clear this. Let's take a look. I don't know how much is in the assignment. I want you guys to realize we are getting towards the end of this chapter. Because there's 6 sections, and right now we just went through section 5. Okay? We have got an assessment coming up. Let's see. There's only 2 problems on this one, and there are... Yeah, do them all. Do them all. So do 1 through 6.